to solve another Leetcode problem, 132, Palindrome Partition 2. So if you've already solved the Palindrome Partition 1, so normally you can start Partition 2. It's going to be similar. So for Palindrome Partition 1, basically we use the backtracking because the length of the S is just 16. But for our problem, it is 2000. And we want to return the minimum cuts needed for a palindrome partition of S. So let me give you an example. So if we have a string like AAB, yeah, we need to cut it, and we need to check the minimum cut. So for example, we can cut at this position, so it is not valid because AB is not a palindrome. Yeah, but we can also cut it from here. So AA is a palindrome, B is a palindrome, and the minimum cut is just 1. But we cannot cut at the ends. So for example, if we have AAA, we cannot cut here or here because this is not a cut. So for example, if we only have A, we cannot cut it, so we're going to return 0. So if we have AB, we can cut it in the middle, so we're going to have 1 cut. We just need to check the minimum cut. Of course, for AAB, we can have 2 cuts, but we want to get the minimum cut. So 2, and this is 1, so we're going to return 1. Yeah. So if we are familiar with backtracking, normally this is just an optimization. We need to optimize the backtracking to BP problem because the length of the string is 2000. Normally we can solve it in ON square. ON square is 10 to the power of 6. It's not a big number. Normally we can pass. Now let's try to write the DFS instead of backtracking. So we're going to start from the index I, and this index would so finally I'm going to return this DFS with a 0 because I'm going to start. Yeah, if it is a 0, it means I will cut it from here. I will cut it. Yeah, so for this AAB, if it is a 0, it means basically yeah, I will cut the first letter. It's going to be like this. So I'm going to starting from this 0. I'm going to check this one first, if it is valid or not. But the final result would be I will use a -1. Because basically I'm going to count how many sub-palindromes I can have. So for example, if I have 2 sub-palindromes, the final result would be DFS from 0, -1. So DFS I means from the ith index to n-1 index, how many palindromes do I have after cutting? So this is the definition of the DFS. Now we can have a check. So if the I equal to n, we're gonna return 0. Basically, this means if it is out of range, there will be no palindrome after cutting. So if I equals to n, so we're gonna return a 0. So otherwise, we're gonna check. So for j in range to yeah, so so this is I. So for j should in range from I to n. Yeah, because we are not sure at which position we're gonna cut, so we're gonna start from I to n. Basically, this means yeah. So this is for example AAB, and so for this j, it's gonna start from this I to n-1. So this is n-1 index. So it can cut here or cut here. So this is the meaning of j. So j basically to have a different split, and then we're gonna check. So that is why it's gonna be starting from I to n. So this n means yeah, it's gonna be like here. This is yeah, let me check. So for j should be starting from I to n-1. Yes, and then if this I equal to n, we're gonna return a 0. Yeah, because if j equal to n minus 1, for example, in this loop, and then j would plus 1. If j plus 1 equal to 0 equal to n, this means if I equal to n, I'm gonna return 0. So if I cut from here, so this is the end, I'm gonna return a 0 because there's nothing. So this is why if I equal to n, I'm gonna return a 0 because for here, definitely it's not a palindrome. So I'm gonna directly return 0. So this means 0 maybe plus 1 plus 1 plus 1, or maybe it's 0 plus 2. Maybe we just have one cut, 0 plus 2. And finally, I just use DFS 0 minus 1. Yeah, now I need to have a valid tag. So if it is a palindrome, I'm gonna have a valid tag. If this I to j plus 1, this means from I to j, if it is valid. So my result would be the minimum of result with DFS to j plus 1. And before j plus 1, I have a palindrome, so that is why DFS j plus 1 plus 1. So that is the total palindrome. So for the result, I need to set it as infinity because I need to calculate the minimum count of palindromes. So the minimum count of palindromes minus 1 will be the minimum cut. So finally, I need to return a result. Now I need to finish this valid function, valid tag. So we can write a valid tag inside a string directly like this. So s should equal to s reverse. Yeah. Because in Python, this is much faster than a two-pointer solution. If you write a valid function, like if you were to write a valid palindrome function, it's going to be much slower. I think basically that's the code. Yeah. Let me just run it to have a tag if it works. Yeah, I didn't prepare this n, so n should be length of the string. Yeah, as you can see, it passed. Now let me submit it to tag if it can pass all the testing cases. Yeah, as you can see, it passed all the testing cases, but it is quite slow. It's nearly 3 seconds. Yeah, and that is also because the testing cases, there's only like 30 or 40 testing cases. There's too little testing cases. But the time complexity, as you can see from here, this is a DFSI, and this is a for loop, and this is a validation tag. So the time complexity is n cubic. Normally n cubic cannot pass for n equals to 2000. Yeah, but I think from the beginning, there's not so many testing cases. It can pass. But if you were to write a two-pointer solution, normally you cannot pass. So let's try. So L and R should equal to 0 to length of s minus 1. Yeah, let's just check the two-pointer solution. So while L less than R, so we need to check. So if SL not equal to SR, we're gonna return a false. Otherwise, so L should plus equal to 1 and R should minus equal to 1. And finally, if everything is okay, we're gonna return true. If you write it like this, normally you cannot pass. So this is the Python things, because Python used the library to use to write the reverse function. Use the C Python, that is much faster. But if you directly write it like this, it's going to be much slower, and you cannot pass, as you can see. Because there are only 37 testing cases, so that is why it can pass for n cubic solution. As you can see from here, we write it cannot pass. But if you can use it like this, you can pass, because in Python, this is much faster than what we write the two-pointer solutions, because that is used to say Python. It is much faster. That is why it can pass. But this is not the best way. We need to solve it in O(n)² solution, and this is n cubic, right? Now, we want to change the valid. We don't want to have it like that because that is in cubic, right? We want to use a dp. Yeah, because normally if we solved the Leetcode problem 5, we should know how to calculate dp from I to j, how to calculate a dp. If we know the dp I to j is valid, is true, normally we can solve it like this. We can get the result. Yeah, but the problem is how can we calculate this dp? So from the beginning, it's going to be 0 times n. So for r in range of n, so this is our dp. Now we need to write another dp. The dp's meaning is to check from I to j. So for example, we have still AAB is to check if this is I, this is j. dp is to check from I to j if this is valid or not. But this dp will be n cubic. If this dp will be n square, and if this dp is n square and the DFS plus memo is also n square, so the final time complexity would be n square. So this is what we expected. Yeah, now we just need to finish the dp. So for Leetcode problem, how to solve the longest palindrome, we should know that if we have a dp, so from I to j, basically we're gonna check from I to j if it is a palindrome. So if the length is from I to j, if the length is less than and minus 2, so this means for j minus I, if it is less than or equal to 2, definitely it is true. It is a palindrome because like A, the length is 2, A, the length is 1, but for B, ABA, if this A equal to this A, and the total length is also less than or equal to 3, so we are sure definitely it's a palindrome. And then for this dp, we can also use another way to check if it is a valid solution. So for this dp, for this string, if from here, we are going to calculate from here to here. So for example, this is I and this is j. We want to calculate from I to j if it is a palindrome. And then we can check from I plus 1, this is I plus 1, and j minus 1. If I plus 1 to j minus 1 is a palindrome from here to here, and then from I to j, it must be a palindrome. So from this way, we can calculate the palindrome of dp real time. So for I, we are going to calculate from I to j. So let me set it. Let me set it like this, I think. So for j in raise, I'm gonna starting from j. So for j in raise n, normally j is larger, so this is for j is larger. J is bigger than I, so for I in range j plus 1. This is because I wanted to check for a character. For example, this is A. So j plus 1, it means the I can equal to j, and because I want to check this character, if this character A is a palindrome or not. Yeah, so for example, from the beginning, j equal to 0, and this I is j is 0 and I is 1, and I can directly check this dp I and j. Yeah, because this I equal to 1, basically it means I checked this character. A, because it's j equal to 0, so this is 1 in a range, so this I is 0. So yeah, now we are going to have a validation check. So if si equal to sj, and we're gonna use j minus I less than or equal to 2. Yeah, because if they are equal, if they are more than or equal to 2, definitely it's a palindrome. Or we can use dp I plus 1 to j minus 1. So we can get the dp I to j, we can set it to true. Maybe from the beginning we can set it to false. always be false. Now we're gonna set it to true. So let's just check this kind of solution. So this for j minus I is just the index. If the index is, it should be less than or equal to 2, not more than. If the index is less than or equal to 2 and they are also equal at both ends, definitely it's gonna be true. Or the subarray in this example, if it is true, definitely it's gonna be true. So this is an O(n) squared solution, and this should be less than or equal to 2. Now I think it's enough to check if it is okay. So as you can see, it works. It passed all the testing cases. Now let me submit it to check if it is faster or not. As you can see, it becomes 1 second, and it is much faster than before. Basically, I think this is enough for such kind of a problem. I think, because definitely from here, we can also write a tabulation of dp, and here is another dp. Definitely, it's going to be much faster. But I think it's enough because definitely the time complexity becomes O(n) squared. Because for here, we are directly check this dp. So dp is just become a search table. So this search table is just checking from I to j if it is a palindrome or not. And this dp is calculated by another dp solution. We just check from I to j if it is valid or not. So the idea is that the formula from here. So if both ends equal, now we're gonna check the length. If the length is smaller, it is valid. If the subarray is still palindrome, now it is valid. It is a palindrome. So that's all for today. Thank you for watching. See you next time.